Okay, so last but not least, when it comes to the compounds, sorry, I'm just grabbing my periodic table, not that I really need it for this one, is polyatomics. Now, this goes with, I'm just going to show you the title here, polyatomic ionic compounds, okay? So this is technically part of the ionic compounds, where you have the charges. We're dealing with ions, okay? So there's positive and negatively charged ions. Now, the difference is what these, I want to say things, what these are they're actually, and you usually get a periodic table at the beginning of the semester, and it has your periodic table on the front, and on the back it has the list of polyatomics. We always give these to you. You never have to memorize these, just so you know. You're always given the chart with the ion, the polyatomics on it, and all you have to do is just use them instead of a nonmetal. Okay, so how these work is they're actually a molecule. So they're molecules of, so they're non-metals. They're groups of non-metals. So as you can see, you got nitrogen, hydrogen, oxygen, hydrogen. There's common ones, and you'll see these ones a lot. So you see hydroxide a lot. You see nitrate a lot. These are ones that we use a lot in our course. But what it is we end up with these molecules that end up having a charge. And that's what polyatomics are. So they're molecules that end up with a charge. So you have this group of nonmetals that will act as a charged nonmetal that we normally would deal with when we do ionic compounds, okay? So treat it the same. The problem is they look scary because there's now more atoms within there, right? There's a group of atoms you're dealing with. But treat it as you would when we're doing our ionic compounds and you're just looking for the charge. But the nice thing is you're given your polyatomics, you're given the charge that you're dealing with, okay? So it's easier, but it looks scarier because now you've got this group, okay? And with the polyatomic, when they're part of the ionic compound, we're not changing the name of them. Okay, it's the name that tells you you're dealing with, you're dealing with polyatomic. If we went and changed the name from nitrate to nitride, which would be the normal nitrogen, the person reading the name would just assume that it's normal nitrogen and not realize that it's nitrate, which is this molecule that has a charge. Okay, so that's the only thing. The thing is, it's giving you the name, you keep the name, and then you just treat it as you would if it was just one non-metal that we were using in our ionic compound, okay? It just looks a little scarier because now you're dealing with a bunch of them. So let's do a couple examples, okay? So same thing as we were doing when we were doing the ionic compounds. You find your charge, right? So calcium, you would look on the periodic table, you'd figure out, okay, calcium has a positive 2 charge. Carbonate, you don't have to guess, you don't have to know, it tells you, like, I'm going to give it to you. You will be given polyatomics. You never have to memorize them, not even grade 11, okay? You get comfortable with some of them because you use them a lot. Like hydroxide is one that we'll use a lot, especially because we have a mini unit on acids and bases, and it's a base. So carbonate, so we look at carbonate, it's got a negative 2 charge. So you have to write out the whole unit, and though I don't know why this sheet has brackets around them, we're going to talk about the brackets, but you don't write them with the bracket. Not all of them. So you write it out. So we have carbonate. So carbonate is CO3. And then we have our negative 2. Okay? All right. So you're just dealing like we would normally, but this is a good example. So I don't put the bracket around it right now. You don't need it. I don't know why it has the brackets around them. On the normal polyatomic chart that you would get in class, there's no brackets. So we have our carbonate, we have our charges. Treat it like an ionic compound. Even though this is like a little molecule here, it still has the charge. So it's going to have the ionic bond, right? It's the ionic bond is because of the positive and negative charges, and they're attracted to each other, which creates an ionic compound. An ionic compound is your metal and nonmetal. Okay, so instead of just your one nonmetal, you have a group of nonmetals, okay, that are acting as your charged ion. That's it. That's what you have to look at it as. You're still getting a group of nonmetals, but they're acting as one, right? So we're still doing the same thing. I don't know why it has it like this, but we'll copy it like it is just so you guys can get used to it. Okay, so you have your C and your +2. And if you're doing it the crisscross method, well, then that's fine. You know, you're bringing it down. So it's going to be your Ca. Technically, since they're both 2's, you do not have to write them, right? Remember that? Because it's an ionic compound, you put it in its lowest terms, so we don't actually have to write them because they're both 2's. So it will just look like this. Okay? Let's do another one. I'm going to do one more because I don't feel like you're grasping it yet, even though I can't see your faces. So magnesium has a +2 charge. Hydroxide, very common one, is your OH -1. Okay? Oh, this is a good one, though. I like this one. This is a good example. Because you do have to use brackets sometimes. Okay? Because what you have to remember is these subscripts in here that are attached to the oxygens, and take note, they all have oxygen. Okay? Except for ammonium. But take note, this is part of the molecule. So remember I talked about your molecular compounds and you can't penetrate inside of it. It's a molecule. You can't build on it. It's one structure. You can have a bunch of molecules beside each other, but there's no lowest term because there has to be a certain amount of the oxygens or, you know, in this case, the nitrogens, the chlorines in that molecule, and you cannot change it or you're changing the structure of the molecule. You're changing the molecule itself, right? Water is 2 hydrogen, 1 oxygen. You know, if you throw something else in there, it's no longer water. Okay, so it has to stay like this. Okay, so same with these subscripts, you cannot change them. Repeat, because I cannot tell you how many kids try to change the number here. You cannot change these subscripts. This is a molecule. You cannot change the molecule. Okay? You can only deal with the charge on the outside. So, for example, let's look here. So you have your magnesium, that's +2. Your hydroxide, which is -1. You have to do the crisscross. Okay, I'm going to show you 2 examples here. Ones we don't write. The 2's we do. Look at here. Which is correct? This one. This, by doing this, you're now telling me that there's 2 hydrogens and 1 oxygen. But this is telling me that there is 2 of these whole hydroxides. So that there's 2 of these OHs. This is telling me there's just 2 H's. Do you see the difference? Please nod your head yes. Okay? This is right. This is wrong. Wrong, wrong, wrong. Okay? So make sure you're paying attention to where those subscripts are. So an example, let me just check this one here. Sulfate. Okay, then that's copper too. I'm going to let you practice these 2. And then I'm going to give you guys a practice sheet to do in this sheet as well. I'm just checking this one too. Okay, it doesn't matter. But if this was something else, you know what, I'm just going to do something else right now so that you can see. Aluminum hydroxide. Don't really think that that's a thing, but we'll pretend that it is, okay? I'm just going to do an example down here, okay? Pretty sure this is not a thing. Aluminum hydroxide. No, let's do something else. Aluminum nitrate. Yeah. Let's do nitrate, okay? Aluminum nitrate, okay? So aluminum, Al, +3, okay? That's +3 charge, okay? Nitrate, looking at nitrate here, we got the NO3, and then it's -1, okay? So we're going to do what we're doing here with these guys did already. Aluminum +3. We have our nitrate -1. Crisscross it down. Again, so another example. We don't have to put the 1, so you can leave that. Which is correct? because I've seen it both ways, and you will not make this mistake. Kids will just add the subscripts together. Wrong, okay? The subscript, okay, this is what you have to understand, is what it's saying is that there's 3 of these whole molecules, okay, for every 1 aluminum. Do you see that? Please tell me that you see that. So this 3 on the outside of the bracket is telling me that there's 3 of these units of nitrate for every 1 aluminum. Do not add subscripts together. Repeat, do not add subscripts together, okay? All right, so you can practice these 2 here. And then just the naming of them I mentioned. We do not change the name of the polyatomic, okay? So the nice thing is it's given to you, all right? So you metal ions, you know, they keep their regular name, right? The metal ones, with the normal ionic compounds, we kept them the same. Sodium chloride, sodium fluoride, magnesium chloride, magnesium, sodium, those metals, they stay the same. Okay? The non-metals we changed to IDE. We don't have to do that for polyatomics. I'm not going to quiz you on, you know, that chlorate is 3 oxygen and ite is 2 oxygen. You don't need to know that for right now. Okay? We're skipping over that this year. That's going to be a grade 11 thing. But what I do want you to understand is that when it is a polyatomic, you keep the name. Sodium hydroxide, okay? That's your hydroxide. You don't have to memorize that. You will be given the list of polyatomics, so you'll always be able to look up their names. So there should be no mistakes there, okay? So, you know, if it was chlorite, you know, sodium chlorite or sodium chlorate, okay? You keep the polyatomic name. You do not change it. If you changed it to IDE, and if you changed, you know, chlorate to chloride, then people would think that it's just sodium chloride, not sodium chlorate, which is a whole other thing. Okay, the polyatomics are all the ones with the oxygens added. Side note, okay, the last thing with the polyatomics is, yes, they all act as the non-metals. They all have that -1, except for ammonium. It's the only one that has a positive charge. So this would replace a metal, okay, and it would be ammonium chloride. Okay, it would end up being all non-metals, but we still, because of the charges, and it's going to be an ionic bond, we treat it as an ionic compound. So this is the only one that is a positively charged one, and all the other ones are negative. But you'll always be given those. Okay, so I have attached, there is no practice sheet here. I didn't attach this one, but I attached, that one. I attached a polyatomic practice sheet for you guys to practice them. I also attached one that's got them all mixed in together, okay? So you have to now try to pick out the polyatomics, the multivalent, the molecular compounds, and to see how well you do with all of them all mixed in, okay? So that's your polyatomic, and come on to Google me if you have any questions.